All right. So, we are doing notes on cross sections, okay? So, a cross section is a what? So, kind of the name implies something, unlike nets, because that was kind of like, what? Okay, cross section is the shape made when a blank is cut through by a blank, okay? So, we could say a solid, or in this case, off to the left here, we have a cone, okay? We'll just say solid, because we're not talking about conics. A solid is cut through by a plane. Y'all remember a plane is a flat surface with no thickness, so it cuts through things, right? Cross sections are usually blank to the blank, but can be any direction, okay? Usually it's parallel to the base. Usually a cross section matches the base because you cut it, you look at it, look at that, okay? We are going to start to try to visualize the plane's intersection with the solids on number 1. So you look at this example. Does everyone see that we have a square pyramid or a rectangular pyramid? And does everyone see right here, I've got a plane that's cutting it parallel to the base, right? So I want you to look at those little dashed lines. When it cuts that pyramid, what shape does it make right here? It makes another rectangle, right? So I want you to notice, the base was a rectangle. I cut that pyramid parallel to the base, and I got another rectangle, okay? Over here off to the right is the way it would look, kind of from above, without a transparent view. But you can see over here, it would still, when you cut it, it makes a rectangle, okay? So, rectangle. If they ask me, what is your cross section? I would say rectangle. Number 2, what is the base of this cone? Is everyone looking up here? Not at your games or whatever, or sleeping. Don't look at your eyelids, look at me. Okay? What is the base shape of number 2? A circle. So guess what? If I cut that cone parallel to that circular base, it's going to make a what? A circle, right? Now you have to imagine actually cutting it and then looking right at it. It's going to be a circle, okay? Now what's the base of number 3? So, 6-sided figure, right? That's a hexagon. So if I cut that hexagonal pyramid parallel to the base, it's going to be hard to draw this, but it's going to make a little hexagon, right? If the base is a hexagon, I cut it parallel to the base, it's going to make another hexagon. All right, now this one's tricky. What is the base of number 4? It ain't no rectangle, because remember, the bases have to be parallel. So this is on its side. It's laying down and taking a nap. Oh, okay, so the base is actually a triangle. And if I cut it parallel to that base, it's going to make a triangle, okay? Yeah, so we're imagining that we're cutting figures. So if you hate geometry, this is your favorite unit, because you're going to be cutting up geometry. Ah! All right, so if you cut that triangular prism parallel to the base, you're cutting and you're making a triangle. Again, we are taking a 3D figure, slicing it, and it makes a 2D figure, okay? So, on number 5, I have a sphere, okay? How about Villanova last night, all right? We got this b-ball, but we cut it in half. So, imagine what the shape is when you cut it. What's it going to make? A circle, right? No matter which way you cut a sphere, you're going to make some sort of round shape, but if it's in the middle, it's going to be a circle for sure, if it's a true sphere. So again, what I want you to know the key phrase on all this stuff was when we talked about, let me emphasize this, parallel to the base. We've been talking about parallel to the base, right? Cool. So look at number 6. It's got a figure, a shape off to the side here. And it asked me, what is the cross-section formed by a plane containing a vertical line of symmetry? I want everyone to see this. This is where we change things, okay? Can everybody underline the word vertical? Vertical. Underline that. This one's different. This one is not parallel to the base. Perpendicular to the base, okay? So whenever you see this key word, okay, vertical, then you guess which way you want to look. Vertical. Vertical means what? It means up and down. So you tell me, if you're looking at that figure, that prism, straight up and down, what are you seeing right here? A rectangle. Thank you so much. So, guess what? If you cut that prism vertically, you're going to see a rectangle, okay? What you see is what you get. If you cut it vertically, and vertically is a rectangle, you're going to get a rectangle, okay? Now, here's how I could show it, okay? Let's say I cut it in half right here. Cut. It would go straight down right here, straight over. And doesn't that look like a rectangle? Well, how do you does look like a rectangle? All right? So, vertically, rectangle. Cool. Hey, guess what? What if I had a pyramid? What do you see vertically for a pyramid? What do you see right there? What is that shape? A triangle, right? So guess what happens if you cut a pyramid vertically? You get a triangle, okay? So here's the rule. Prisms vertically make a rectangle. Pyramids vertically make a triangle, cross section, okay? So, number 2, what is the cross section formed by a plane that is parallel to the base? What's the key word there? Parallel to the base. So now I'm going to look at the base. That's the key word. Is everyone with me? Because I see phones and hands, and sleepy eyes, and distractions. But look at the base here. What is that base shape with 6 sides? Hexagon. So guess what? If I cut it anywhere parallel to the base, it's also going to make a hexagon. Let's see if I cut it up here. 1, 2, 3, 4, 5, 6. That's a hexagon cross section. Again, that cut is called a cross section. So we make a hexagon by doing that, okay? So when you see the keyword vertically or vertical line of symmetry, you know you got to look straight up and down vertical. If you see the keyword base, then you tell me what the base shape is. That's the cross section. 100. All right, look at number 8. Now, by the way, what's this shape over here called? Cylinder, okay? So, number 8, what is the cross section formed by a plane containing a, what's the key word? Vertical, okay? Very important word, vertical line of symmetry for the figure at the right. Now, this is going to kind of blow some of y'all's minds, okay? Because you kind of got to think a little different. I don't know where my shape went. But either way, if I take a cylinder and I'm looking straight at it, like straight at it, what shape does it make? A circle? No, I'm not talking about the top or the bottom. Oh, here we go, here we go. Someone said it. I'm going to try to show you real quick. So, I have a cylinder, right? Now, if you're looking straight at that, here, bet. All right, if you're looking straight at that without any distortion, it should look like a rectangle. Now, this is not a perfect example, so this is straight, straight, and straight, okay? So, I'm telling you, believe me or not, okay? If you look at the side of a cylinder, you should see a rectangle if it's perfect, right? And that's what happens. Like I'm looking vertically, rectangle, okay? So the vertical cross-section of a cylinder is a rectangle, okay? Don't say circle because we're not talking about the base. That wasn't the key word. The key word is vertical. So think vertically. Number 9, though, 9 says, what's the cross-section formed by a plane that is parallel to the base? Key word, base, right? What is the base shape of a cylinder? Hey, it's a circle, right? So if I cut it up here, it would still be a circle. That cross-section is a circle, okay? So that's what we've been talking about. Not just cutting it to cut it, but we're cutting it because these are cross-sections. Now, I'm going to really blow your mind, so stay with me. Flip it over. What happens if we take cross-sections and then we do this crazy thing where we rotate them, okay? So this is going to be a little bit bizarre, but notice what it says right there. We can rotate the cross-section to create a new three-dimensional object, okay? Now I'm going to do my best to show you what I mean by this. It's going to take me 2 seconds to make this. Okay, it says when a rectangle is rotated around a line that runs along one side of the rectangle, a cylinder is created. Oh no. And I guess, you know what, we're going to do that tomorrow, alright? Boy howdy. So, again, I need that 3D Nets assignment done, so make sure you've got it done. If you got extra time in class today, make sure you're doing that. It's all around the room. You can't do it at home, so you got to make sure you do it here. All right.